for our second semester. Before you start viewing the video, make sure that you turn off the TV, you turn off the phone, that you are in a place where you can pay attention to this video and take good notes. Our objectives today are that I can define a function and I can determine if a relation is a function. So before we get started, let's start with some vocabulary. Our first vocabulary is relation, and a relation is a set. Oops, let me get my pen going here. There we go. A relation can be a few different things. It can be a set of ordered pairs, and that's what we see most often in math class. And so an example of an ordered pair could be the ordered pair 1, 3. A relation, also like the word relation, a relation shows a relationship between two things. So sometimes we're going to be taking a look at some relations and it doesn't involve numbers, it just involves some words, and those words are showing a relationship between those two things. So we'll see some examples of those in a couple of minutes. Let's continue then with our next vocabulary word, which is domain. And if you look back at where we had our ordered pair in relation, we had an x coordinate and a y coordinate, and our domain is always going to be our x values. So let's write that in. Domain will be your x values, and then your range will be your y values. And then a function is going to be a special type of relation. So this is a special relation. Where none of the x values repeat. Let's continue writing this over here. X values repeat. Notice in the definition that it's none of the x values repeating, so we don't care if the y values repeat, but in order for something to be a function, the x values cannot repeat. You'll only have one of each of the x values. So let's take a look, scroll down here so we can take a look at some examples. So first we have here examples of relations that are functions. So we have example A here. And here we have an example that is what we call a mapping. So this first column here, these are your x values, and the second column represents your y values. So if we were to write ordered pairs, this would be 1, 3, and then 2, 6, and 3, 9. Notice that this is an example relation that's a function because none of our x values repeat. We have a 1, 2, and 3. Moving on to our next relation, here notice is an example of relation where we don't have any numbers. So remember earlier I had said that we'll see some where we have just words. So we have purple, pink, and green. Those are all colors, and 4 is a number. So again, same thing. These are your x values. This is your y value. And you're looking at that column on the left-hand side to see if any of those words repeat to determine if it's a function. Notice that each of the words is only used once. Purple is a color, pink is a color, green is a color. They're all going to the same y value, but that doesn't matter. We're just looking at the x value. So this one is a function. Example C, we have our ordered pairs. So we have 0, -1, 1, 2, 2, 5, and -1, -4. Again, looking at your x values, which are the first numbers in the ordered pair, none of the values repeat, so that's what makes it a function. Now, with example C, we can also find the domain and the range. So domain, remember, are your x values, and when we're stating the domain, we're going to write the numbers in numerical order, so starting with the smallest number. So we'll start with a squiggly bracket, and our smallest number is -1, then 0, 1, and 2, and then we'll close that off with another squiggly bracket. Our range is going to be our y values. So again, we're going to write this in what we call set notation with these squiggly brackets. And looking at now our y values, our smallest y value is -4. Next one is -1, 2, and then 5. And then we'll close that off with squiggly brackets again. Next section over here, these are examples of relations that are not functions. So you'll see some relations that are functions and some that are not. So if we look at example A, here again we have another mapping. If we look at this, this is telling us we have the ordered pair 4, 2 and 4, negative 2, and then 9, 3 and 9, negative 3. So each x value is being used twice. So that's what makes it not a function. If we look at example B, pizza goes with cheese, it goes with sausage, and it goes with veggie. Notice that these examples that are not functions, the item that's on the left-hand side has 2 or more arrows coming out of it. So if you see 2 or more arrows coming out of something on the left-hand side, then it's not going to be a function. And then we have sandwich goes with both turkey and ham. Example C, we have our traditional ordered pairs, so 8, 1, 5, 1, 8, 2, and 6, 7. Notice that 8 is used twice for x value, so that's why it's not a function. But even though it's not a function, we can still find the domain and range for example 3 here at the bottom. So let's start with our squiggly brackets. It takes a little practice to write those, so don't worry if you can't draw those too well. We'll keep practicing. Our x values, so we're finding the domain, will be 5, 6, and 8. And the 8 is used twice, but we don't have to write it twice when we're writing out the domain and range. And then our range, we're looking at our y values now. We have 1, 2, and 7. All right, if we scroll down now, we'll see some of you tries. So you can try those in class. Let's turn the page to page 2. Now we're going to be taking a look at some graphs and determining if that graph is a function. And we're going to do that by using what we call the vertical line test. So a vertical line, remember, is a line that goes up and down. So we're going to be drawing lines through graphs. So let's take a look at our first section here, examples of relations that are functions. So we have this graph here, and it's this curvy line here, the solid line. And we can draw a vertical line through it. So the dotted line is our vertical line for our vertical line test. And we're looking to see how many times it hits the graph. In order for it to be a function, we only want the vertical lines to hit once. So notice that this line is hitting just once. And if we were to draw more vertical lines, we would see that they would all just hit once. If we go to our second example here, we have this graph. And we have a vertical line going through it, and it hits only once. And same thing with this V graph here. We have a vertical line, it hits only once. So relations that are functions, let's write ourselves a note here that the vertical line hits once. That's an S there. There we go. Examples of relations that are not functions. So this is where the vertical line is going to hit more than once. So if we look at our circle graph here, we have a vertical line and it hits 1, 2 times, so that's not a function. Or we have this weird looking graph here that's just zigzagging all over the place. We draw a vertical line going through here and it hits 1, 2, 3 times, so that's not a function. And then we have this graph here, vertical line is hitting twice, so that's not a function. So you're always looking to see how many times that vertical line hits your graph. If it hits only once, then it's a function. If it hits more than once, it's not a function. So now if we scroll down, we have some U-tries that you can do in class. And then our last section on this note sheet are equations and functions. So our example number 11 says, write a function rule where each output of a function is 6 less than the corresponding input. So you may be reading that right now and asking yourself, I don't even know what an input or output is. So let's define a couple of these words first. So we're going to be writing a function rule, so that's going to tell us that we're going to have to write an equation. I didn't mean to cross that out. That should be underlined. And then each output, an output is going to be your y variable. And then at the end we have an input. Your input, it will always be your x variable. So we're going to be writing an equation, and that equation will have a y and an x in it. So what we're going to do with this sentence really is just translate it like we did problems last semester. So write a function rule, so that's an equation where each output, so that's going to be a y, of a function is, and remember the word is means equals, and next it says 6 less than the corresponding input. So we really want 6 less than x. Remember, less than was our special word that told us subtraction, but we had to switch the order. So in English, the 6 came first. When we translate, the 6 comes after the subtraction sign, and then the x will go in front, so that our equation is y equals x minus 6. So here we're just really doing a simple translation, but you have to remember that output means y and input means x. And that's it. You don't have to do anything else. You were just asked to write an equation. There's our equation, and we're all done. So not a lot of work for that. We just have to remember our translation rules. And then we have a U-try. If you have a last page to your packet, make sure that you fill in the statements, what you can do, what you still don't know. Maybe circle a problem if you don't understand it so that you can ask questions in class tomorrow.